Welcome to the deep dive. We are jumping right back into Chapter 3 of our source material, Web Design for Backend Engineers.
Yeah, and today's mission is a big one.
It really is. Today, we are tackling the final and probably the most elusive design principle in the stack, which is consistency.
Right, and we're talking directly to you, the listener, the senior back-end engineer who's constantly managing architecture.
Exactly. And instead of relying on some, mysterious artistic intuition, we're going to look at UI design through a lens that you already breathe every single day.
Oh, I love this approach. We're talking infrastructure,
Yeah.
DevOps, configuration management.
Yep. Because the earlier chapters, they gave you the tools to fix a single page. But today is about keeping an entire application from just falling apart at the seams as it scales.
It's a completely different challenge.
It is. Okay, let's unpack this. I want to start with a concept from the text that is going to be incredibly familiar to you. Configuration drift.
Oh, yeah. The silent killer.
Right. Picture a perfectly templated Terraform deployment. Beautiful, clean infrastructure as code.
A dream.
Every single server in your fleet is identical down to the byte. It's a flawless baseline. But then, a late-night incident happens.
It always does.
Someone manually SSHs into one instance, and they tweak a timeout setting just to get a critical service back online.
Just a temporary fix.
Right, temporary. But then next week, someone else bumps up a memory limit on a totally different node because some heavy cron job keeps failing.
And let me guess, nobody commits these changes back to the repository.
Exactly. And fast forward 6 months, that quote-unquote identical fleet has diverged invisibly into a totally fragmented mess. And suddenly nobody can figure out why certain requests are randomly dropping on certain nodes.
What's fascinating here is how perfectly that maps to UI design. It's the exact same mechanism.
Really? Like one-to-one?
One-to-one. Think about it. In UI, it starts with the developer copying an existing button component. They look at it and think, this feels a bit tight, so they just bump the padding by 2 pixels.
Right. Harmless. Right.
Totally harmless in isolation. But then, a few days later, another developer needs blue background for an alert notification.
Okay.
They grab a color picker tool, and they select a slightly different shade of blue than your company's actual brand standard.
I see where this is going.
And then a third developer builds a nested settings menu, and they decide to use a 14-pixel label instead of the 13-pixel label used everywhere else.
Wow. But, individually, none of those micro deviations break a layout, right? A button with 2 extra pixels of padding still fires its on-click handler.
Exactly. It doesn't throw an error.
Right, it doesn't crash the server. But collectively, as the user navigates from, say, the dashboard to the settings page, they get this creeping, visceral feeling that nothing quite fits together.
It just feels cheap. It subconsciously degrades their trust.
Yeah, that makes total sense. But wait, why doesn't this kind of creeping degradation happen with the other design principles we already covered?
That's a great question. There's really sharp contrast here.
Because, we talked about hierarchy, white space, alignment, proximity, and contrast.
Right.
Why don't those rot the same way?
Well, it comes down to scope. Those first 5 principles, they are highly localized.
Okay, meaning what?
Meaning you can completely fix the hierarchy or the white space of a single landing page in total isolation. You never have to look at another screen.
Oh, right. You just fix that one page.
Exactly. But consistency is a cross-cutting concern. It requires every single page, every component, every interactive state in the entire application to agree on the same set of decisions.
So what does this all mean for a scaling team? Because if I'm a solo developer building 3 pages, I can keep the design consistent just purely through memory?
Sure. You just remember to use 16 pixels.
Yeah, I literally just type 16 on the 3rd page because I remember it from the 1st page.
But the moment you scale to a team of 5 developers building 30 pages,
Oh, yeah, that's impossible.
you cannot rely on 5 different human memories to synchronize an arbitrary pixel value. Relying on human memory for UI at scale is just a guaranteed failure.
It's like trying to manually remember IP addresses instead of using DNS.
Exactly.
Yeah.
Just like infrastructure requires strict configuration management, UI consistency requires explicit codification.
Okay, here's where it gets really interesting. Because the source text introduces the practical fix for this, and it's called design tokens.
Yes. And it sounds like a trendy buzzword, but it's not.
Not at all. It's literally just environment variables.
Exactly.
Think about it from a back-end perspective. You would never, under any circumstances, scatter hard-coded database credentials throughout your application code.
That'd be a nightmare.
You put them in a central environment variable, and design tokens do that for CSS.
Right. So your primary color is no longer a hard-coded magic number like the Ch.3 B82F6.
That's just floating around in 50 different files.
Yeah, you don't do that. It becomes a token named primary color. And your standard spacing isn't 32 pixels, it's space large. So if you need to change a value, you change it in one central place.
Oh, wait, let me push back on this a bit.
Go for it.
If I have to tokenize every single thing, every shadow, every border radius, every tiny pixel tweak, doesn't that just turn into a massive unmaintainable dictionary of like 1,000 variables?
Oh, yeah. That's a huge trap.
Yeah.
But if we connect this to the bigger picture, the source text is super clear about this. You don't need a massive, monolithic design system to start,
Okay, so how many do you actually need?
honestly. Putting just 5 to 10 tokens into your CSS custom properties
Yeah.
is enough to start.
Just 5 to 10, that's it?
Yeah, like a few core colors, a couple of spacing values, and maybe 3 font sizes.
Wow.
If you just establish those, you make arbitrary drift structurally impossible for those components
Yeah.
because developers have to pull from that list.
They can't just invent a new blue because the hex code literally isn't an option. They have to use var dash dash primary color?
Exactly. You're constraining the choices to prevent drift.
Okay, so that's how we prevent future drift.
Right.
But what about the current application? Because, I mean, let's be real, most listeners are dealing with an app that already has 2 years of sloppy, hard-coded CSS baked into it.
Oh, absolutely. The drift is already in production.
So how do we audit the current app to find these bugs?
Well, the text has a great method for this. It's basically running grep across your interface.
A cluster-wide health check. I love that analogy.
Yeah, and the key is you have to do it side by side.
Okay, break that down for me. How does the audit actually work?
So you open the application in 2 browser tabs right next to each other. But they have to be completely different pages,
Like what?
like your global settings page on the left and maybe a user analytics dashboard on the right.
Okay, 2 different contexts.
Exactly. And then you rigorously compare identical elements.
So, like, the primary submit buttons on both pages.
Yes. You look at the buttons, the headings, the spacing between sections, but you don't just eyeball it.
Right, because our eyes are terrible at that.
Right. You use browser dev tools to inspect the computed styles.
Wait, computed styles? That's a really important distinction. Why not just look at the CSS classes in the source code?
Because the source code will lie to you.
Mm.
You might see class equals BTN primary on both pages, so you think they're identical. But there might be some rogue legacy CSS file overriding the margin on one of those pages.
Yeah, the cascade.
Right. The computed styles pane gives you the absolute mathematical truth. It shows exactly what the browser rendering engine finally decided to draw on the screen.
That is so crucial. And this is a huge blind spot for developers, right?
Oh, completely. Because single-page audits totally miss these errors.
Yeah, because if you're just looking at the settings page, an 8x16 button looks perfectly fine in isolation.
It looks like a button.
Right, and then tomorrow you're working on the dashboard, and a 10x20 button also looks perfectly fine.
But side by side.
Side by side, it's a glaring violation. The user feels it immediately as they click between pages.
Exactly. And that's why the text recommends the 15-minute full audit.
Right, the 15-minute audit. Let's outline that.
So it's 5 minutes of that side-by-side cross-page comparison in DevTools, just hunting for structural drift.
And then?
And then 10 minutes of rapid pass-or-fail diagnostic checks on a single page using those earlier principles we talked about.
The result isn't some, like, massive 6-month redesign.
No, not all.
It's just a fast, actionable punch list of seconds-long fixes, changing a 14 to a 16, swapping a hard-coded hex for a token.
And it instantly transforms a disjointed app into a coherent product.
Okay, but let me play devil's advocate for a second.
Sure.
If we strictly enforce these tokens, and we make every component identical everywhere, doesn't the application just become this monotonous, contextless gray box?
That's a really common fear.
Well, because what about semantic meaning? Like, some things need to stand out.
Right, and this raises an important question from the source material. There is a huge caveat here.
Okay.
Consistency does not mean monotony.
Mm-hmm.
Intentional, meaningful variation is a core part of good design.
Give me an example.
Think about a destructive action versus a constructive one. A button to permanently delete a database absolutely must look different from a button to save a user profile.
Oh, totally. The delete button should be red or have a warning icon. It should feel dangerous.
Exactly. Same with system states. An error notification has to visually diverge from a success notification.
Right. Or like business logic. If you have a SaaS product, your premium tier features should probably look a little more elevated or distinct from the free tier.
Yes. These breakages in consistency are deliberate. The underlying semantics of the application actually demand it.
Okay, but as a back-end engineer managing the system, how do I tell the difference between a deliberate semantic variation and just sloppy accidental drift?
It's actually really simple. The text calls it the articulation test.
The articulation test, how does that work?
You literally just ask the developer or yourself, can you articulate exactly why these two buttons look different?
Oh, I see.
If you can explain the semantic reason, like this one is red because it deletes data and this one is blue because it saves data, then the variation is fine.
It's justified.
Right. But if the answer is, I don't know, I just thought it looked better, or I copied a different snippet,
Then you failed the test.
you failed. It's accidental drift, and you have to eradicate it.
That is such a clean binary rule. I love that.
It takes the guesswork completely out of it.
It really does. So, to summarize the key takeaway for you today, you need to treat your UI design with the exact same rigor as your infrastructure management.
Absolutely.
By using environment variables for CSS, meaning design tokens, and running strict DevTools-driven health checks, you can conquer the UI without ever needing an artistic eye.
You're just managing state and configuration.
Exactly. Looking ahead, our next deep dive into the source material is going to tackle typography.
Oh, that's a huge one.
It really is. The text says it's responsible for more of a page's visual quality than almost anything else. 90% of web design is really just getting the text right.
I completely agree with that.
And obviously, down the road, we'll eventually explore things like color theory, layout systems, full components, and accessibility.
There's a lot of great material coming up.
For sure. But before we go, do you have a final thought to leave everyone with?
I do, and it builds right on that DevOps theme we've been using.
Let's hear it.
If UI consistency is ultimately just a form of configuration management, and your browser DevTools is basically your monitoring system, at what point does interface design simply become a branch of site reliability engineering?
Oh, wow.
Right? Could you theoretically write an automated test suite, like a visual chaos monkey, that intentionally breaks CSS tokens in staging just to prove how resilient your layout is to arbitrary data?
A visual chaos monkey. That is both terrifying and brilliant. Something for you to mull over until next time. Thanks for listening.